right, class, this is lesson 3-3. We are learning to do linear equations with more than one step. So one thing we always need to remember is to combine like terms. What that basically means is the ones that look similar, they need to be put together. So let's just say if we had something, for instance, a heart and a smiley face. Are they the same thing? No, those are not like terms. But if I had heart plus smiley plus heart, I could combine my two hearts. Those are like terms. So I would get 2 heart plus 1 smiley. Now, of course, our work's not going to look like that, but it gives you an idea of what like terms means. Okay, so now let me tell you this. What if we have 1x plus 2? Well, these are not like terms because this one has a variable and this one does not. But if I had one more number, then I can combine. The 2 and the 3 are similar because neither one of them have variables. So I can compare those and put those together, which means I'm going to get 1x plus 5. And that's combining like terms. And then to properly write this would be x plus 5. All right, so let's try some that are a little bit harder. Let's try one that looks like this. We have 8x plus 6 plus 3x minus 2 equals 37. So the first thing we want to do is solve for x. But before we can solve for x, we have to make these down to 1x instead of 2 numbers with x's. So what I'm going to do is combine my like terms. I'm going to bring down my x's. So I have 8x plus 3x. They're the only ones that have a variable with them. So combining those two, I get 11x. Now I'm going to compare my other numbers. I have 6 minus 2 are my other like terms. When I put these together, I get plus 4. And now I'm just going to bring down my 37. Well, I still have a pair of like terms here, my 4 and my 37. So I need to put those together. If I'm going to move this 4 to the other side of the equal sign, I have to do the opposite operation here of addition, which would be to subtract the 4. Because what you do to one side, you do to the other. The 4's cancel, and I wind up with 11x equals 33. Now this should look like some math that we've done earlier in the year. So you would know now to get this x by itself, I need to get rid of the 11. They're being multiplied, so I'm going to do the opposite and divide. Because what you do to one side, you do to the other. And I wind up with x equals 3. So that's how you go about solving equations with like terms. Now, what if we had one that had some fractions in it? That always tends to throw kids off. So let's look at one of those. What if we have 5n over 4 plus 7 over 4 equals negative 3 over 4? All right, so the first thing we want to do is get rid of these denominators. It's really nice on this one that all the denominators are the same. So this may look kind of funny, but it'll make sense. If these are all being divided by 4, then the opposite would be to multiply by 4. What you do to one side of the equal sign, you have to do to the other side. Okay? Because I am multiplying by 4, I am actually canceling out these denominators with the multiplication of the time, or with the 4. So same goes here. So basically the 4's just all get wiped away, which is nice because we got rid of the fractions. So now I'm just going to bring it down. We have 5n plus 7 equals negative 3. Okay? We want to get n by itself, so we're going to do the opposite here. We're going to get rid of the 7. So we're going to subtract 7. What you do to one side, we do to the other. These cancel. 5n falls down. They're both negative, so we keep the sign and we add. So we go 7 plus 3 is going to give you 10. Next step is going to be to get the n by itself. So we're going to divide by 5. What you do to one side, you do to the other. 5 goes into 10 2 times, but you have a negative there, so n equals negative 2. Okay, so that's how we do it when we have fractions. You want to get the common denominator across the bottom. That always helps. Or a number that can go into all the ones across the bottom, and then divide it out that way by multiplying and canceling out the denominators. Let's show you one where the denominators are not the same. We have 7x over 9 plus x over 2 minus 17 over 9 equals 2/3. Well, as you can clearly see, all of these denominators are different. So I need to find a number that all of them have in common. A number that 9, 2, and 3 all have in common. You can hockey stick these and find your common denominator, but I'll just go ahead and tell you 18 is a number that they all have in common. Okay? So I'm going to multiply both sides by 18. Now when I do that, 9 goes into 18 2 times. Now picture this is also being multiplied by 18. This is also being multiplied by 18. They all have their own little 18. 2 goes into 18 9 times. 9 goes into 18 2 times. And then way over here, 3 goes into 18 6 times. All right. Hopefully I haven't lost you. When you multiply by 18, you're basically multiplying each segment by 18. So they all get their own little answers. Now when I do this, I'm going to multiply this number by the top number. So all my denominators, if you notice, are crossed out. So now I'm just going to multiply all the numerators. So I have 2 times 7, which is going to give me 14x, plus I have 9 times x, which is going to give me 9x. And then this is a subtraction, bringing down my subtraction here. Now I'm going to have 17 times 2, which is going to give me 34. And then up here, I have 6 times 2, which is going to give me 12. Okay? Now we're going to go ahead and combine our like terms, which we have 2 x's here. So we have 14x plus 9x gives us 23x minus 34 equals 12. Now I want to get this x by itself, so I need to get rid of this 34, and I also need to combine these two like terms because they're the only two numbers left that don't have a variable. So I'm going to add 34. And when I add 34, this one cancels. I'm going to write it over here. I get 23x on one side equals 46. Now to get the variable by itself, I need to divide the 23. Divide the 23. The 23's cancel, and my x winds up equaling 2. All right, guys, I hope this helped you on your homework.